right, so 5.2C lesson, we're looking at proportionality with graphs and tables, and then answering some questions from those graphs and tables. So number one, Tony ran in a marathon. The graph given below represents the distance she traveled over the course of the race. Complete the table below. Okay, so this time, notice that we're given the graph and the table's empty. Seems like before, we've done the opposite. Okay, we were given this and we had to plot it on the coordinate plane here. Okay, so we're going to go ahead and pull out values of time in hours and the miles run. Okay, so here's the time in hours. So at 0 hours, she's gone 0 miles. At 1 hour, she's gone 6 miles. At 2 hours, she's gone 12. Okay, and I can pull whatever values I want out of here. I can jump around if I want to. I can go to 4 and go up to 24. And then 5, 30. All right. Part B, is this relationship between time and distance proportionally related? Justify your answer using the table of values, graph, and equation. So yes, this is. I can see it is because I've got this. Oops, I put 1 here. Sorry, guys. It should have been a 0. All right, so I've got this. I always look at this 1 first, and then I see if I can write that pink 6 on all of them. And yes, I can. 0 times anything is 0. All right, this guy, straight line through the origin, linear through the origin. All right, so from this table, the time spent running, okay, if you wanted to say the independent variable can be multiplied by the same constant, 6 in this case, right, to get the distance. Okay, every time in a table, every single time in a table, we have always said the independent value gets multiplied by the same constant to get the dependent value. I've changed the independent value and dependent value to match this context, but it's the same thing every time for a table, if it's proportional. Okay, the graph, it's linear and through the origin. Okay, remember the word linear means it's a straight line and then it goes right into 0, 0. Okay, and an equation. Okay, an equation of the form dependent variable equals constant times the independent variable. Let me scooch this up, guys. There. Okay, in this case, okay, the dependent variable, let me scooch it back down. The dependent variable is, I'm going to use M for miles, equals 6, and then the independent variable is T for time. T for time. T for time. Okay. You absolutely need to know table, graph, equation, and justifying using them if a situation is proportional. That is the main point of this module. Okay. Okay, where do you see the constant of proportionality in the table, graph, and equation? So in the table, where the 1 hour corresponds, I'll move it up in a second, to 6 miles. Remember in a table where the x value, t value in this case, better called independent variable, is 1. So that's where you see it there. In the graph, it's where the independent variable x is 1 and dependent variable is 6. So on the graph, 1 on the graph on the independent axis matches 6 on the dependent axis. This is where you see it on a graph right here. Okay, this is where you see it on a table. This is where you see it on the graph right here. Okay, the equation. All right, so it's the constant in the equation. Scooch that up. It's the constant in the equation. In this case, it's the coefficient in front of t. Okay, suppose another runner started at the same time as Tony and in 3.5 hours ran a distance of 20 miles. Which runner was going faster? How do you know? All right, well, we know the rates of Tony. We know the unit rate of Tony. Okay, let's find the unit rate of this other runner. So 20 miles. This kind of goes back to the beginning of the module. 3.5 hours. And we want that to be equal to 1 hour. Okay, so we're going to divide this. Divide by 3.5 here and here. And if you do that, you get roughly 5.714 miles per 1 hour. Okay, so this person goes fewer miles. Okay, Tony goes 6 miles in an hour. This person goes fewer miles in an hour. Okay, if you're going fewer miles in an hour, you're going slower. Okay, so Tony is faster since she covers 6 miles in an hour. And this other runner goes about 5.7 miles in an hour. All right, so here is this kind of current situation relating back to some prior stuff from this module. Okay. All right, next page. It says examine the graphs below and do the following for each problem. Number 1, we're going to fill in the table. Number 2, we're going to write an equation that relates x to y. Number 3, we're going to determine if the situation represents a proportional relationship. Number 4, state the constant of proportionality. Okay, remember, if it does not represent a proportional relationship, there is not going to be a constant of proportionality. Okay. All right, so remember that this is your x and this is your y. So I'm going to pull out this point right here. That's 0, 0. Then I'm going to pull out this point right here, and that's 1, 2. 2, 4, 3, 6. Okay, take a look at this. 1, 2, 3, 4, 5 different points on this graph, and there are 4 rows. You might have pulled out a different 4 points than I did. Okay, and also you need to understand that this line goes on forever. This graph right here is just a little kind of snapshot of it. It goes forever though, okay? All right, so we're looking for that number, and I always go to this 1. I want to see if 2 relates everything in this table, and look at that, it does. So this 2 is going to go ahead and be my constant of proportionality. This is proportional because I have the same pink 2. The constant of proportionality is that 2. And what point represents the unit rate? It's the 0.12. Okay, this guy. I'm going to pull out 0, 0. I'm going to pull out 1. It looks like 1.5. I'm going to pull out 2, 3. I'm going to pull out 3, 4.5. All right, so if I multiply this by 1.5, that works. Okay, you can also think of it as 3 halves. Okay, if I multiply this by 1.5, it works. Same with this, same with this. Okay, you could have this pink number being 1.5, or you could have this number being 3/2. Let's see if this gets a little clearer. It looks a little fuzzy to me. It's a little better. All right, so this is going to be y equals 1.5x. I'm going to put or y equals 3 halves x. Those are the same thing. Okay. Yes, it's proportional because that pink number is the same throughout. And also we can look at it that it's a straight line linear into the origin. Okay, so yes, it's proportional. Constant of proportionality, 1.5 or 3 halves. What point on the graph represents the unit rate? 1, 1.5. Okay, you could have put 1, 3 halves. Okay, this I guess you could have also had the equation 1.5x, y equal 1.5x. All right, part C. 0, 0, 1, 1, 2, 2, 3, 3, and so on. Okay, the equation. Hopefully you see that this is just multiplying by 1. So y equal 1x or y equal x, it doesn't matter. They're both the same. Is this proportional? Yes, it is. Again, linear into the origin, same pink number. That's how you know. Okay. Constant of proportionality, 1. And then the point that represents the unit rate is 1, 1. Okay, this guy, 0, 0, 1, 3, 2, 6. Coming in here and I'm multiplying this by 3. So y equal 3x. Yes, it's proportional. The constant of proportionality is 3. And 1, 3 represents the unit rate on the graph or in the table. Okey-doke. Last page coming at you here. We've got a situation on this one. Okay, Milo and Sarah each bought chocolate cinnamon bears from different candy stores. Milo paid $3 for 2 pounds and Sarah paid $5. I'm sorry, $5.25 for 3 pounds. Assume the rates are proportional. Okay, so we're going to let Milo be purple and we're going to let Sarah be the pink information. Okay, so if Milo paid $3 for 2 pounds, So 2 pounds for $3. Okay, let's think about 0 pounds. Okay, and this doesn't have to be in order. The last page, they all seem to be in order. I'm going to kind of look at it like this. Okay, so if 2 pounds is $3, 0 pounds wouldn't cost anything. 1 pound would be $1.50. 3 pounds would be $4.50, and 4 pounds would be $6. Okay, so I multiplied these by 1.5. Okay, so the unit rate. You know what? Let me go. Let me go down here. The unit rate for this guy. Okay, be very careful. Unit rate. The unit rate is where 1 is for X, and you need to have the units. So this is $1.50 per 1 pound. The constant of proportionality is 1.5 or 1.50. The point on the graph that represents the unit rate, 1, 1.5, and an equation that relates X, the pounds, to Y cost, Y equals 1.5X. All right, let's get Sarah's information. Sarah was 3 pounds for $5.25. Okay, I'm gonna do 0, 1. Oops, I'm doing pink. Sorry, guys. 0, 1, 2, and 4. Okay, 0 pounds would be $0. 1 pound. If 3 pounds are $5.25, that's going to be $1.75. 2 pounds is going to be $3.50. And then 4 pounds is $7. Okay, and the number that we multiplied by on each of these is 1.75. The unit rate, be very careful, unit rate, $1.75 per 1 pound. The constant of proportionality is just the number, the numeric value of that unit rate. The point on the graph that represents this is 1, 1.75, and an equation to represent this would be y equal 1.75x. All right, now we're going to graph. We're going to graph both on the same grid. I'm going to use 2 different colors. Okay, so this is the amount in pounds. This is our X value. This is our Y value. And this is going to be our cost in dollars. All right, let's do Milo first. Okay, so Milo 2.3, 0, 0, 1 $1.50, 3 $4.50, and 4 is 6. Okay. If you're only in a pencil, you definitely want to stop now and draw a line through it. Okay, if I plotted all of Sarah's points on this graph in a pencil, I would wonder whose goes with whose. Okay, so I'm drawing a straight line through because guess what? This is just a snapshot. Milo may buy 10 pounds and be way up here, right? All right, so that's Milo. Let's get Sarah's information on there. So we've got 3 and $5.25 would be about there. 0, 0's there. 1 $1.75 is here. 2 and 3.50s here, and $4 and $7 is going to be up here. Okay, so let me get Sarah's graph. Okay, so if you don't have two colors, you would write Sarah by that line, and you would write Milo by this line. I didn't need to do that because I'm color coded. Okay, but if you're just using a pencil, which is fine, just make sure you're labeling who is who on that graph. Okay. All right, who got the best deal? Who got the best deal? Okay, is everybody good with Milo got the best deal because he paid $1.50 per pound versus $1.75 per pound. Okay, Milo got the best deal since he paid $1.50 per pound compared to Sarah. Sarah's $1.75 per pound. Okay, so nothing really new, guys, in this. Just kind of bringing it all together from section 1 and the section 2.